This is a turntable I just inherited, the AR-XA. It's arguably the first audiophile turntable. It's from the early 1960s. It was very popular, made for over a decade. Very compact, too. It's the depth of a record jacket. So if you have very tight spacing, you can even put this on any shelf that can hold records, which is kind of nice. And because the dust cover lifts off rather than hinges backwards, you don't have to worry about you needing extra depth for the clearance of the hinging dust cover. In this video, I'm going to talk about this design, and I'm going to show you by demonstration what makes it so special. So if you're into science, you're really going to like this video because that's all this video is about. Even if you don't care about this turntable, you'll still learn an awful lot about what you want in a turntable design for the best sound. This is a belt drive turntable. Belts help minimize vibration from the motor from entering the platter. It's fully manual, no start, stop button, speed selection, pitch control. All you get is an on-off button and nothing else. You have to put the needle on the record yourself. It has no arm lift even, nothing. So it's as bare bones as they get, as manual as they get. There are a lot of things that make this turntable special and give it the phenomenal performance even to this day by current standards. But the main one is the floating subchassis. Notice when I press the record surface, everything bounces around. There's a 3-point floating subchassis design that this turntable actually was pioneered and is now copied by many other people that helps keep noise out of the system. And there are many different kinds of noise besides just footfall in the room, motor noise. It helps eliminate all different kinds of noise. I'll be talking about that later. Another thing I wanted to point out is that a lot of people say, you know, it's a pretty good turntable, but it needs a better arm. This arm is phenomenal. I think they see the plastic on the headshell and that scares them off. They figure it must be some cheap design. It is anything but cheap in terms of its engineering. I'll be describing and demonstrating what makes this so special in the video. People often have trouble wrapping their head around this turntable because the performance is top-notch, yet it was dirt cheap for its day. $78, and that includes the tonearm. I think all you had to buy is your cartridge and you're up and running. Anyway, I'm going to show what makes this turntable so special, and I'd like to clarify that this is a completely unmodified turntable. I've replaced the mat and the belt, which wear out over time. That's just true of any organic material. But other than that, it's a completely unmodified design, even though this turntable happens to be one of the most highly modified and upgraded turntables in all of history. Despite being cheap, the AR turned out to be the single most important turntable of all time. That's a direct quote from Hi-Fi News, May 2009, which called this turntable a milestone. And the reviewer who wrote those words, by the way, has reviewed turntables that cost $100,000, such as the TechDAS Air Force One. So this is a very special turntable, and I'm not going to talk about what makes it great. I'm going to show you what makes it great. Stand by. So many turntables use stable balance as opposed to neutral balance. And people confuse the two because they go, I don't get it. It's stable, it's balanced. There are different kinds. Stable balance means it's constantly hunting for a specific neutral position. For instance, this one is hunting for this position. Turntables that work this way, you establish neutral, stable balance. You then apply your tracking weight, for instance, this nickel that I've inserted over on this side, and that's your tracking force onto the record. The problem is, as the record goes up over a warp, there's additional downward force, and when the record goes into a dip, there's upward force. In fact, it can lose contact, and that causes skipping and distortion. So you don't want stable balance, you want neutral balance. Another disadvantage to stable balance, what you see here, is that the tilt of the shelf that the turntable's on will vary the downward force as well. So you have to recalibrate and readjust your turntable every time you change position, whereas with a neutral balance tone arm, you can set it up on one shelf and then freely move it to any other shelf in the room. So the AR arm I've taken out of its bearing to show you the side view. The counterweight is sunk. It's not directly on axis to the tone arm itself. Notice it's down. There's a specific reason for that. In order to have neutral balance, you can't have your weights where the fulcrum, compared to the fulcrum, you can't have them both above the fulcrum, both below the fulcrum. You have to be able to draw a straight line from the center of mass of the counterweight through the pivot, through the center of mass of the cartridge. It's okay to have things that are too high and too low, but the center of mass of the two sides have to draw a straight line through the fulcrum, and that's indeed what the AR arm does. So this turntable still needs a lot of cleaning. There's a lot of dirt on it. Wanted to show a few things on it. Take off the record. This is just a flimsy foam mat. The original one was heavier and had a raised outer ring. As you can see, this platter is filthy, but I've cleaned the parts that I believe are the important parts to clean, namely this outer ring. If that surface is not clean, you'll get lots of flutter. If you use an old belt, you'll get flutter. And the pulley, which controls whether you're doing 33 1/3 or 45 RPM, that also needs to be clean. Unfortunately, it's got some oxide on it, so I don't think I'm getting as good wow and flutter results as ideal if it were brand new and clean. You can also store the belt on the inner part of the platter itself. With the weight of the outer ring as well, it's about 3.5 pounds. That's a little bit more than, for instance, a Project debut turntable. So this is sort of like a $300 to $400 turntable in terms of the platter weight, to give you an idea of its flywheel momentum. If you start it up, you can keep playing it for about a minute or so, just because of the flywheel motion. For instance, I'll start my stopwatch here. While that's spinning, I'm going to demonstrate neutral balance. I've adjusted the balance so that this tone arm is neither up nor down, nor has a weight or tracking force. And notice if I put it below record surface, it stays there. If I put it at record surface, it stays there. Or if I put it above record surface, it stays there. That's because the balance of the arm is neutral. Typical tone arms, when you adjust it for the neutral setting, it will hunt. It will go like this, trying to find the point of static balance, but not neutral balance. But this tone arm, if you adjust it appropriately, stays exactly wherever you put it. Now, once you get that, you then can dial in the amount of tracking force that you want. So as you see, it's still spinning, and we're coming up on a minute. I thought I'd do two demonstrations at once. Neutral balance as well as flywheel momentum to keep the speed very, very exact. So let's check the tracking force. 1.962. The tracking force, it's okay if it's off by 10% or so. In fact, they give you a huge range for this particular cartridge of 1 to 2 grams, depending on if you use its stabilizing brush and other factors. So that's a pretty broad range of 1 gram. But what happens if the turntable is tilted? Say, for instance, I put this on a shelf that's not level, and we're about to do that. I'm going to put a bottle cap under the back corner of the left and the right so that the whole turntable is tilted up like this. So I have to readjust my scale because it doesn't like being tilted. Turntable doesn't mind being tilted, but the scale has to be recalibrated every time you tilt it. Reset the setting. So my tabletop is flat. However, the turntable is now tilted downward in the front by 2 degrees or so. Let's see what the tracking weight is now that the turntable is not on a flat shelf. $1.95. So as you see, there's less than a 10% change, even though we're on a drastically off-balanced shelf. So there's no need to buy an expensive bubble level for this turntable. Once you set it up with the proper tracking force on one shelf, you're free to move to any other shelf. Leveling is not nearly as critical thanks to the neutral balance arm. When the AR first came out, it had one of the lowest mass tone arms on the market ever made. It's partly because of the headshell. People look at the headshell and they sometimes think, oh, that's just cheap plastic. They actually made the headshell first out of metal, like the rest of the arm, and decided it was too heavy, so they converted to plastic. Yet it's very rigid because of this half-box design I'll talk about in a bit. Complete with the headphone wiring in place, the weight is 6.978 grams. That's less than a microscopic H303 headshell, less than a Technics SL1200 headshell, less than any of the 3 Project headshells in aluminum, wood, or carbon fiber. So this headshell is not very heavy at all. In fact, if you compare it to a nickel weighs exactly 5 grams. This one does. They vary a little bit by year, by the way. Anyway, this headshell is very lightweight, yet very rigid and inflexible. This box design helps keep it very solid so there's no twist or warp to it. I'll give a demo of what that box construction gives you. So why does AR use this box design instead of just a flat slab like most other people? It's to add rigidity, strength, and inflexibility. I'm going to show you a demo of that using empty Tic Tac boxes. What I've done is I've prepared 2. Sorry about the noise outside. One is sort of traditional headshell design, which is just a flat slab that you connect your cartridge to. And this is more like the AR design, which is a box with an open bottom. Why make it this way when you could make it this way? And the answer is added rigidity with only marginal increase in mass. Let's take a look at how much this weighs. This Tic Tac box is 5.8 grams, whereas this one with the sides removed is 4.787. So we have saved roughly a gram by removing the sides. But what about the strength of the box? How has that changed? Here's the demo. This is just a little block of wood to elevate it above the turntable dust cover, whose condition I don't care about because it's already scratched up. And as you know, nickels weigh 5 grams each. How many can it support? 5 grams? 10 grams. Ooh, it's starting to droop a little bit at 15 grams. Yeah, there's some serious drooping at 20 grams. So how much stronger is the open box design compared to this? Well, rather than waste all that time, I'll show you. It can support a pound. This is a pound of beans. So instead of 15 to 20 grams, it can hold 454 grams, yet it only adds 1 gram of mass. Other than the curly cue of the wire, there's no anti-skate on this turntable. AR actually put out white papers saying they didn't believe in it. They said it's an extremely minor force. Plus, it's not constant. The amount of skating that you get in the beginning of the groove, the first grooves versus the last grooves, is quite a bit different, as well as the volume level, the modulation of the disc of the recorded passage also greatly affects skating. So anti-skating of a constant amount doesn't really make sense. Plus, they say it's like such a small difference, you can effectively get the same thing by increasing your tracking weight by 10%. So I've calibrated the app. Now let's see what the speed tests are. You want to do this while the needle's in the groove. You want to use one of the middle songs because there's drag from the record. The display gives me a final reading at 20 seconds, but there we go, 33 1/3. Hope you can see that. The lighting is hard to get this display for the phone. And 20-second mark will be in just a moment. I have to talk over the music or else the copyright police will shut us down. So let's see what the final results are. I've already entered the name of the turntable from previous tests. You can upload it to the database later so you can read my results online. But there we go, 33 1/3. With wow and flutter 0.13. I'm not sure if you can see that. Let me zoom in. Is this in focus? So I've taken a few different readings over the past few days. They always vary a little bit. Let's share this to the world database. So now that I've uploaded to the World Turntable database, let's see how I scored. It's fetching the current entries. They have over 300. I'm at the very top, but that's alphabetically. So Acoustic Research AR-XA is the first alphabetically, but select accuracy ranking and check this out. I appear at number 8, and that's out of 316, so that's pretty darn good. If you select it, you can look at more detail at my wow and flutter ranking. Stays within a 0.04% window up and down, and see how it happens every white line. Those are each revolution. So since there's an anomaly each revolution, that tells you it has something to do with the platter, not the motor. And if it's the platter, that means there's some weight anomaly. For instance, a half-pound cell phone balanced on top of it. If I may have better readings than what this is saying if I didn't have this darn heavy half-pound cell phone on top, complete with case. It's almost half a pound. So number 8 out of 316. I am very psyched. Here's the Sting movie soundtrack record I'm using for a lot of this video. Looks flat, right? Look, when we put the needle in the groove, though, you'll see a slight up and down motion. We can zoom in on this. These are called micro warps, and they potentially can discolor the sound because they cause a very slight altering of the pitch. AR addresses this problem by keeping their tonearm pivot very low, barely above record surface. You can actually tweak it a little bit. They recommend 1/8 of an inch above record surface is sort of ideal, and we'll talk about why they do this. As the tonearm has to negotiate a warp up and down by putting the pivot height at record surface height, you minimize any forward or backwards motion. Most competitors, the way they do it is their pivot point is up high too much. I'm estimating by about 21, 22 millimeters, such as this little elevator device I'm about to show you. If you put your pivot height too high, and I'm exaggerating at the moment, but if you put it too high, what happens is the arc, the swing of the arc, or if I put it way too high, see how the needle will be scraping forward and backwards within the groove in order to negotiate that arc? That's the problem. That's what causes the wow when you have a bump in your record. And it can even be audible on very tiny warps on some records, but with the AR turntable, you never hear warps. And it's because they minimize the problem by keeping the pivot point at record height. Almost all other brands, including extremely expensive $28,000 tone arms such as Swedish Analog Technologies, put their pivot point above the record surface. By my estimate, most brands do it about a thumb width higher than it should be, which is roughly about the size of this little pen that I've cut down. I'm going to elevate this tone arm by that amount to show you why you want your tone arm at surface height rather than elevated. And we're going to do that with a gigantic warp. We're going to use this bottle cap that I've put some orange tape on so it's easier to see. And this bottle cap is 6.69 millimeters thick. So that is a gigantic warp. So now as the record plays, the needle is going to go up and down by a gigantic amount because of that artificial warp that I've induced into the record. Now this warp is actually on the very outside of the record, and I'm playing one of the inner tracks. So just so you know, it's not exactly 6 millimeters where the actual record is playing. We're at normal AR pivot height, which is just barely above record surface height. This is a spectrum analyzer, an oscilloscope, and a frequency counter. And we're going to see how the frequency varies on the warp using AR's height, AR's pivot height. So this varies from 997.5 to 1002.5, and you can see the waveform jump back and forth about one wavelength. So this is what happens on a giant warp when you're playing the record with the pivot at AR's record height. We're not going to change anything on the turntable, on the record I mean. However, we're now going to change the pivot height. I'm going to elevate the pivot height by 1 nickel, which is about 22 millimeters with this little puck that I made out of a pen. This is a pivot height elevator. We drop it in. So now everything is the same. However, our tone arm is now elevated to typical competitor height. Now notice the waveform even goes as high as 1005, and notice that the movement of the waveform is no longer just one wavelength, it's several wavelengths. And listen to the tone. So by keeping the pivot height at record height, AR keeps a vertical warp wow half of what the competition does. And this is a giant warp. But the point of these demonstrations, which I know a lot of people are going to watch this video just on laptop speakers, by showing you exaggerated conditions such as a giant warp, showing you how much better the AR is with that, you then can deduce that, okay, on a normal size warp, it's also going to be a lot better. So I've now extracted the nickel height elevator. I removed the gigantic elevation warp, and now we play the normal flat surface record with the 1 kilohertz test tone at AR normal height. There's still a little bit of wiggle from wow and flutter. You know, this is not a digital technology. Analog is always going to have some jitter, some shake to it. But on the AR, normal size warps are inaudible. Even giant ones are hardly audible, but that's not true of the competition. And you can see the waveform jump back and forth about one wavelength. So this is what happens on a giant warp when you're playing the record with the pivot at AR's record height. Now notice the waveform even goes as high as 1005, and notice that the movement of the waveform is no longer just one wavelength, it's several wavelengths. And listen to the tone. So this is the test rig I'll be using for the seismograph tests with the cell phone. Just want to sort of show you what we're using here. The turntable has no feet whatsoever, direct wood-to-wood contact to the speaker. The speaker also has absolutely nothing below it. It's directly coupled to my floor. We'll be using the Sting soundtrack. So I just wanted to sort of show you what it is we're using as we conduct these tests. Instead of using 4 rubber feet, such as most turntables, this turntable had internal shock absorption. This is what it was. It's 3 of these mounted in an equilateral triangle, and guess what the center of the equilateral triangle is? The center of mass of the entire mechanism. So the bounciness is made very stable by having the 3 points equidistant to the center of mass. Nobody else had done that, and it was such a successful system. It was copied by VPI, Lynn, Ariston, Thorens, Bang & Olufsen. A whole bunch of other copies have been made by many other companies. It was very successful, and you're about to see why. So my cell phone is now showing a seismograph showing vertical vibration. If I tap the record surface, you can see the vibration and it scrolls across the display. I drop this little rubber washer on the turntable surface. You get a little pulse. But the question is, okay, so it can sense vibration, the seismograph can. How immune is the turntable to external world vibration? We're going to measure that. We're going to do it actually while playing the record. These metal objects are proof of vibration detectors. When these rattle around, you know, wow, this turntable really is being shook. Whereas if I didn't have these here, you wouldn't really know. Maybe I have some kind of special rubber suspension or something like that. This is a 16-ounce hammer from Stanley. And let's start up the record. Unfortunately, this display is going to rotate around, so you have to just sort of look at it closely. There's a little bit of shimmy from the vibration of the motor when it starts up, but the vibration goes away as soon as it gets to correct speed. So there we are at correct speed. Let's play the record. I have to talk over the music, unfortunately, or else the copyright police are going to shut us down. So 16-ounce hammer. What happens if something hits the floor you have your turntable mounted on, or the shelf? Nothing. It doesn't skip, no seismograph reading, no thump in the speakers, no skipping of the needle. What happens if you actually whack the plinth surface itself? You see, these things are rattling around, so you know I'm not pulling my punches. There's a little bit of registration on the seismograph. I don't want to break my turntable, so I'm not going to go too wild on this. But the immunity of this turntable is uncanny. And to show you what this seismograph would be doing if I were hitting the surface of the record itself, it would look like that. So here's the turntable. I've turned off the motor so it's not spinning, although the needle is on the record. And I've put little pieces of orange tape on my preamp volume knob so you can sort of see where it's at. This is minimum volume, this is maximum volume. Notice I can turn it all the way up to full. All you hear is hiss. That's true of all phono preamps, no matter how much you spend. If you turn them up high enough, you're going to hear some hiss. Now, I want to point out that this turntable is now resting on the speaker reproducing the sound. Let me show you. Those are a pair of AR-3s, the world's first speaker with a dome tweeter, also introduced by Vilcher at AR. And they used acoustic suspension, also his invention, first shown in the AR-1. I've only connected the top speaker. I haven't connected the bottom one. I don't know if you can see it. I've put a little piece of orange tape on the speaker right here, and that'll kind of show you the motion of the woofer. So as you can see, this is indeed the woofer making the sound. Let me turn down the volume. Also, these are upgraded tweeters from Allison, so they may not look like what you're used to if you are familiar with AR tweeters and mid-ranges. Anyway, here we see the volume level and the needle mounted directly to the speaker, no interface of rubber or anything else whatsoever. You can crank it to max and get absolutely no acoustic feedback. And that's because of the floating subchassis, the fact that the tonearm and the platter are isolated from the outside world. On most turntables, there's a coupling between the outside world and the playback system. For instance, I can defeat the AR system by putting the needle on the surface of the plinth. In these more typical situations, you get acoustic feedback at a certain volume level. Hear that horrible sound? And we even have a little bit at 50% volume. So that would be the maximum you could play a normal turntable because of the lack of acoustic feedback isolation. However, with the AR, you can crank it to max. No acoustic feedback. This is an incredibly loud volume setting, I should point out. Let me show you what it would be like with music. Let the record come to speed. If you look at the volume here, it is completely immune to external vibration. You can't hear any thump, no skipping. And that's thanks to the 3-point floating subchassis. So the acoustic feedback problem that this solves, even if you mount your turntable on the speaker itself, normally a complete no-no for any other turntable. Most people even have to be careful even having the turntable close to the speaker system. Being able to mount it on top of the speaker is absolutely unheard of. Anyway, its ability to ignore vibration, which I'll now show you what the competitors are like with the mounting to the plinth itself. Let me turn off the motor. The fact that you can only turn it up to a certain point before you get acoustic feedback. That doesn't mean, okay, if you stay at this level or lower, you're safe. Because it gets worse as the volume level of the music gets higher. I'm doing this now at 0 volume, so this is not necessarily a safe level if we were actually playing music. Plus, listen to that acoustic feedback before it reaches full outright howl level. That kind of causes a murkiness in your bass response, even at lower volume levels. People may have to wear headphones to hear this, by the way. I don't know if laptop speakers are going to reproduce this very well. But the fact that the AR is completely immune to this problem makes it so much better for music reproduction quality. It is not just some gimmick that lets you dance around the room while your turntable is playing, which some of the competitors kind of implied in their advertisements because they couldn't replicate it. This next test, I'm just going to read straight from the original white paper, Edgar Vilcher's article in Audio Magazine, A New Turntable Arm Design, because he says it best. The tracing capability of an arm, ability to maintain proper needle-groove contact, may be tested by subjecting the arm to severe adverse conditions, such as those provided by a badly warped record. Some years ago, C.G. McProud suggested a tracing test that consisted of playing a 45 RPM placed eccentrically on the turntable, that is, with the spindle on the edge of the large inner hole. The arm is swung back and forth, creating, of course, severe wow due to the change in path length. But the needle is expected to maintain contact with the groove. So let's see how this does on the McProud test. He was a editor for Audio Magazine, I believe. So we're not judging the sound, we're just seeing, will it maintain contact with the grooves or will it fly out of the record grooves? It seems to stay in the groove. This also demonstrates why it's important that a record must be perfectly concentric. If it's off just a little bit, it'll sound bad, even just millimeters. That's another reason why the AR brags that they have an extremely accurate spindle diameter. When the AR turntable was released, at least one reviewer griped that the records would sometimes stick to the spindle. That's sort of true. That does sometimes happen, but you can easily just push it off as you're lifting the record off. But there's a very specific reason they have as large a spindle as possible, and that's to keep the center point exactly in the center of the rotation of the grooves. The NAB standard, National Association of Broadcasters, says that a broadcast quality turntable should be 0.283 inches in diameter. Let's check out what the AR is. 0.283. This makes sure that as the record rotates, the path length doesn't vary. As we saw in the McProud test, if the record varies left to right as it rotates, that causes wow. And it can happen from two reasons. Your spindle is not the right size, and so there's a little bit of play when you put your record on. The indication for that is when you put the record on, you can actually hear a slight click noise as you move the record left to right. One is if the spindle is too small, but another reason is sometimes the hole is just punched in the wrong position. There's not much you can do about that unless you have a certain Nakamichi turntable that I once was a dealer for that actually would reposition the platter to correct for the position of the spindle. So you see a paper clip such as this is 1 millimeter thick, almost exactly 1 millimeter thick. And this will allow me to place the record onto the platter with 1 millimeter of error. These will let me elevate the record above this surface. So the record is now in error by 1 millimeter in terms of the concentricity, if that's a word, of the grooves to the rotation. Let's see what it sounds like. That's wow from just 1 millimeter error. I'm going to turn down the volume. So if you see your headshell moving back and forth left to right, that means you are not concentric to the actual grooves and you're experiencing some degree of wow. Whether it's audible or not on the particular music you're listening to, that's another question. But it's easiest to hear this problem with flute and sustained piano notes. So here's an underside view of the turntable from the floor looking up. I'm sort of upside down from this sitting on a chair. I can't see this, so I'm sort of operating by braille. But you have 3 suspension points. The springs are here, here, and here. And the center of the 3, the center of mass, is somewhere around here. When I push upward, instead of this floating subchassis wiggling around, instead I can sort of lock it into position, and that turns it off. So this is sort of our A-B switch where I can demonstrate what it does. This is 3-point suspension off, and this is 3-point suspension on. So when I press the transport against the top plinth, I've disengaged the floating subchassis, and you no longer have immunity to acoustic feedback. So in this part of the video, we're going to talk about rumble, room rumble. Right now you're seeing a spectrum analyzer showing the frequency response of the music. It goes from 20 hertz to 20,000 hertz. We're zooming in on the bass area though. This scale is from 0 to negative 80 dB, and it migrates in time upwards. Every line is 1/10 of a second, so you can sort of see what's going on. We're just playing music at the moment, but we'll get to low frequency bass in just a moment. There are different kinds of rumble. One is rumble in the recording itself. You can't really get rid of that, but the master tape and the cutting lathe that made the record has rumble. We're now playing the lead out groove on this album, and we're now about to hit the inner groove. Here, we just hit the inner groove. The turntable motor has rumble. Hopefully the belt keeps that at bay. It's not perfect though. The turntable platter just spinning causes rumble. It's not a perfect system. And finally, what I'm going to show you in this video is room rumble. Most reviewers don't even talk about this because it's usually obscured by all those other kinds of rumble, but because AR does such a good job at getting rid of rumble, you start to hear things that you've never even noticed before. And if you're saying, well, I don't have rumble in my room, yes, you do. Rumble is caused by heating, ventilation, AC, hard drives, DVRs, washing machines, dryers, street noise, construction, sometimes wind on the outside of the building, airplanes, trains, subways, even light fixtures give off low-frequency noise. And you may think, well, I don't notice any of that stuff, so what does it matter? It still can alter performance of playback, and people who have to use subsonic filters or rumble filters, better called infrasonic filters. Subsonic would mean it's slower than the speed of sound, but if you have to use a subsonic filter, it means you're also compromising your deep bass response, so you're not going to hear 20 hertz the way you're supposed to. So people with good subwoofers aren't going to like using subsonic filters. Anyway, AR gets rid of this problem, and I'm about to show you. Notice you can see the floating subchassis in action. This is the spindle, and the needle's playing the final inner groove here. So let's do the rumble test. So I devised this test myself. I call it a grind to a halt test. I think you can tell why it's called that, because that's what we're going to do. We're going to kill the electricity to the turntable and watch it grind to a halt. So it stops spinning. Now all this noise you see here, this low frequency noise, is room rumble. It's a combination of room rumble and phono preamp noise. And all turntables have it. It's just a function of how quiet is it. This is what most typical turntables will be like, but I've disengaged the AR's floating subchassis. Look what happens when I re-engage the floating subchassis. All the rumble goes away. Isn't that nice? We're going to kill the electricity to the turntable and watch it grind to a halt. So it stops spinning. rumble goes away. Isn't that nice? So the AR's floating subchassis gets rid of all sorts of low-frequency noises, not just from the record, not just from the motor, not just from the external speakers playing music loudly. It also gets rid of room rumble. Nail. I don't want to break my turntable, so I'm not going to nail this all the way in, but you can actually nail on this turntable and it does not skip, and you don't even hear a thump, thump, thump in the speakers.